Hello, y'all, and welcome to lesson 27 of my DP chemistry curriculum. Today we're working on structure 3.1.1. We're going to be talking about the periodic table, how it consists of periods, groups, and blocks. We'll identify the positions of metals, metalloids, and non-metals within the periodic table, as well as understand the four blocks of sublevels, S, P, D, and F. You do have a periodic table within your data booklet, section 7, I believe, and that will be the tool we use. So, with that intro out of the way, let's get started on the periodic table. It is the best cheat sheet you'll ever have, and it has two main levels of organization. The first being what we call groups. You may also hear it referred to as families. Groups and families are our vertical columns. So they are vertical, whoops, vertical columns. And what makes them so important is that these elements are grouped by similar properties, specifically similar chemical properties. Now, we'll go into a little more depth about that, but it's good to know that groups and families do share those similar properties. The other way the periodic table organized is in what we call periods. Heck, it kind of gets a name from that. So periods are the horizontal rows. Horizontal rows. Now, these are elements that also, so in addition to just being in the same horizontal row, these are elements that have the same highest occupied energy level. So we discussed this in a previous lesson when we talked about electron configurations, that everything in the same horizontal column has the same energy level that's highest occupied. So when we look at our periodic table, so I'm just going to do a rough sketch of it, very rough. Up and down, these are groups, and left, right, these are periods. Forgot this bottom section. So with that said, we have another subway of dividing it. So I'm going to import an image that I prepared. So there we go. We have our metals and non-metals. So you'll notice that on our periodic table, we have our metals all on the right side, as well as this entire lower area. Our non-metals are all over here. And then we have these metalloids that are right in the middle. Metals all share similar properties, and non-metals all share similar properties, and metalloids kind of have properties of a little bit of both. Now, you'll also notice hydrogen just chilling over here in the metal section. It is a non-metal and does act like a non-metal. However, we'll discuss in a bit why we actually put hydrogen here and why sometimes you'll also see helium right here next to it. You may already know the answer if you think about an earlier section. So we need to be able to recognize that line. Generally, one of the easy ways to remember this kind of deviating line is you can just kind of draw a zigzag or that diagonal from boron to astatine, and then take everything below it, because sometimes polonium acts a little bit like that. But you can take everything below it except for aluminum, which is clearly a metal. You use it probably every day with aluminum foil, and you can assume these will be metalloids. Anyways, moving forward, we also have another major grouping, and that's the table is grouped by electron sublevels. So when we did electron configurations, we talked about electron sublevels. Specifically, each group of the table has the same type of sublevel with the same electron occupancy. So you might be saying, well, what do you mean by that? Well, let's take an example. Let's just look at group one. Looking at group one from my periodic table, hydrogen all the way to francium, we'll kind of look at our points starting with hydrogen, lithium, sodium, and sure, we'll go to potassium. So when we look at these elements, hydrogen's electron config looks a little like this, 1s1. Lithium's looks like 1s2, 2s1. Sodium's is 1s2, 2s2, 2p6, 3s1. Potassium's is going to be 1s2, 2s2, 2p6, 3s2, 3p6, 4s1. And we can go further, but we really don't have to. We can already notice that in group one, we all end in S1, S1, S1. So all elements that have the electron configuration S1 at the very end will be a group one element. We can kind of extrapolate this further to our periodic table. The entire table itself is subdivided into blocks. So if you look at the table, and I have to draw our lanthanides and actinides, we have a few clear blocks. And I'm gonna highlight helium because helium, like I said, might deserve to be elsewhere. And so as we look at our table in these sections, we notice that we can just check them out based on what their sublevel is. The sublevel refers to the block. So we actually name this the S block, sorry, not P, D block, P block, and F block. So these are the four sections of the periodic table, along with helium also being in the S block. Specifically, it's the 1s2, because it actually acts kind of like it belongs right there. So this is it. This is all there is for the basics organization of the periodic table. Make sure you keep these things in mind. So hopefully this helps and have a great day.